Good day, class. Welcome to CPE3 Programming Logic and Design. So for this video, we're going to discuss about flowcharts and pseudocode. Flowchart. So what is a flowchart? For us programmers, flowchart is a way of describing a system or an application in such a way that we use shapes and also arrows to represent the flow of a system. Flowcharts are written with program flow from top to bottom of a page. So each command is placed in an appropriate shape box and arrows are utilized to control the program progress. Here are the shapes that are used in a flowchart. So we have an oval, which indicates the beginning or end of the program. And a parallelogram is point where there is a input or output from the program. Okay, and then rectangle indicates the assignment of the value to a variable, constant, or parameter. So the assigned value can be the result of the computation, and the computation would also be included in the rectangle. Now a diamond shape, it indicates a point where a decision is made. So this diamond uh, is a decision shape wherein it can be answered by either yes or no. Okay, so the double-lined rectangle indicates the use of an algorithm specified outside the program, such as a subroutine. So we use this double-lined rectangle if we are trying to call on a function from another program. Okay, now circles can be used to combine flow lines, and then for arrows, it indicates the direction and order of program execution. Okay, so we use these arrows in order for us uh, to create a routine, or let's say a direction of the program. So where after the shape, or let's say the decision where it will go next. So we use arrows in order to point which is the next shape to be executed. So for example, we have a flowchart to get the sum of two numbers. So remember that an oval is used to make the start and end of a program. So we use an oval here at the top. Remember that this is a flowchart that is from top to bottom. So the flow of execution in a flowchart is from top to bottom. Now, so start, and then after the start, we use an arrow to point to the next step. Okay, then it says here input first number. Now the parallelogram is where there is input and output of the program. So if you want to enter a number, let's say first number, since we're going to add two numbers, so we need to enter the first number and then second number, and then for printing we also use parallelogram. Okay, so actually these two inputs here, you could just combine this. For example, input first and second number, you could do that. But to make it more readable in the eyes of readers, we could just divide them in different shapes. Okay, but you could also combine them in one shape. Okay, so for example, input first and second number. Okay, so that's also allowed. Okay, next, so we have here a rectangle. Rectangle is used to represent a process. So what process is that? Calculation. So we calculate the sum of first and second number. Okay, so uh, you could also write something like this. So sum, I'm sorry for the handwritten. So sum is equal to first number, or let's say n1 plus n2. Okay, so you could also replace this input n1 then input n2 to make it more synchronized, okay, on our calculation. So calculate the sum of first and second number. If you want to make it more readable, you could just input n1, input n2, and then calculate the sum of n1 and n2, or just replace it as like this. Sum is equals to n1 plus n2. Then place it here. Okay. So after the calculation, you could just print the sum. Print or display is allowed since it is actually it is actually a common word, and I think the reader would understand what you are trying to say here. So print sum or display sum. So after displaying the sum, the next step is to end the flowchart. Okay, so that's how you add or to get the sum of two numbers. Okay, start, get the first number, second number, or n1 and n2, and then calculate for the sum, and then of the first and second number, and then assign it to sum, and then after that is we print the sum. So whatever the value of n1 plus n2, so it will be assigned to the sum variable. Okay, and then we will print sum at the end of the flowchart, and then that's where we end the flow of this execution. Okay. Next, so flowchart to determine if a number is even or odd. So here we have again an oval for the start of the flowchart. Now after the start, we will ask the user. So let's say input a number. So we're not gonna actually explicitly put the number that was entered here. So we're just going to put input number. So let the user think of a number. Okay. Now let's say I wanted the number to be equal to 5. Okay. Now after this, so we will go to the diamond. So diamond is a decision shape wherein we ask questions that can be answered by either yes or no. Okay. So is number, actually this is number modulus division 2 or modulo 2 is equal to 0. So there should be actually a question mark here. Okay, I forgot. Is number modulo 2 equal to 0? So we're trying to ask. Okay, and it can be answered by yes or no. Okay, that's one important part in creating or in using a decision shape like diamond. Okay, so we're trying to ask questions that can be answered by yes or no. Now, is number modulo 2 equal to 0? Now if yes, display even number. If no, display odd number. Okay, so what does the modulo mean? Okay, the modulo operation is a division, and then the answer is, or we're trying to divide two numbers and then get its remainder. Okay, so for example, I imagine that the input number or the number is equals to 4. Now if we try to divide it by 2, 4 divided by 2 is 2, and then what is the remainder of that operation? 4 divided by 2 is equals to 2, remainder 0, right? So the remainder, we're trying to get the remainder of these two numbers. Now, for the case of, let's say for example, the number is equal to 5. So 5 modulo 2, meaning to say we're trying to divide 5 by 2. So 2 divided by 5, so that's 2.5. But actually here, we're trying to get only the remainder, which is 1. So 2 plus 2 is 4. So there's a lacking of, or let's say there's an excess 1 on the operation. So 5 modulo 2 is equals to 1. And it is not equal to 0. That's why it's odd number. Okay? So here is another example. 7 modulo 4. So that's a percent symbol. So modulo 4 is equal to 3. Okay? So 7 modulo 4 is equals to 3, because if you divide 7 by 4, there is an excess 3 to make it another 4. Okay? So since there's an excess 3 to divide it by 4, so the 3 is the remainder in this operation. Okay? So another thing is, for example, 10 modulo 6. So the remainder is 4. Okay? So 6 divided by 6. So that's 1. And then there's a excess 4 in this 10. Okay? So that's the remainder. Okay? Okay. So here, let's say I entered 5 on our number. So 5 modulo 2 is 1. So 1 is not equal to 0. So the answer is no. So we go here, display odd number. And obviously 5 is actually an odd number. Okay? So for the case of, let's say for example, number is 6. So 6 modulo 2. So 6 modulo 2 is actually 0 and it's equal to 0. So that's why it's yes. So we will display even number. Well, obviously 6 is an even number. Okay? So after displaying even number or odd number, we will go to the end shape, okay? Which is an oval. Okay? Now, so let's create a flowchart to display 1 to 5. Now, so here's the answer. So we have start, and then at the rectangle, again, the rectangle symbol is for the operation, or we're trying to assign a value to a variable, so that's also an operation. So we use rectangle. Okay? So we will set n is equal to 1. So this is the starting point. Set n is equals to 1. Now we have the display n. So display n, so that's 1. And then at the after the display n, or after displaying n, which is 1, we will go to the next shape. So we're not going here at the right side. We're going down. Okay? So look at those arrows. It's pointing down. Okay? So here we have a decision shape, which is a diamond. So it's trying to ask us if n is greater than or equal to 5. Is n greater than or equal to 5? Actually, n is equal to 1. Okay? And 1, is it greater than or equal to 5? It's no, because 1 is less than 5. So if no, set n is equal to n plus 1. Okay? So we're assigning again a value. Set n is equals to n plus 1. So maybe we could use a table in order for us to trace this. Okay? So let me open my Microsoft Excel. So maybe we could try to create a table of this. Okay. Let me minimize this first. Okay, so set n is equals to 1. So we have n. I hope that you could see my Microsoft Excel. So we have here n, and then display n, and then we also have is n greater than or equal to 5, and then set n is equals to n plus 1. So as you notice, class, I have created a table here, and then I put those values in those shapes as a column. So we have n here as 1, so we put 1 here. Okay. Display n. So what would be displayed? It's 1. So let me center it. So since our n is equals to 1, so initially it's 1, we will display n. So the value of n is 1, so it is displayed as 1. So we will check if this is yes or no. So the only value that can be entered here is yes or no. So is n greater than or equal to 5? So this is no. And And then here we have set n is equals to n plus 1. So we will plug in the previous value of n here. So the value of n is 1, plus 1 is 2. It will be assigned to n. Okay? So now n is equals to 2. So where do we go next? So after assigning a new value to n, so now currently n is equals to 2, we will go back to display n. Okay? So going back to display n, which is here, so we will display n. And n is currently 2. Okay? So we will display 2 here. Now we will check, is n, which is equal to 2, greater than or equal to 5? So this is no again. And then we will add 1 to n. So n is 2 plus 1, that's 3. Right? And then going back to our display, we will display 3. And then we will check again in our diamond. We will check if 3 is greater than or equal to 5. Since 3 is less than 5, we will say no again. And then we will add 1 to our n. So n is equals to n plus 1. We will plug in 3 to n. So 3 plus 1 is equals to 4. Okay? Next, we will display n. So currently n is equals to 4. So we will display 4. And then we will go again to our diamond. Is n greater than or equal to 5? So this is no. And then n plus 1. Okay? So n is currently 4 plus 1 equals to 5. Right? So we will go back again. So this is where we set the value of n. So we will go back again to display n. So we will display 5. Now we will check again. Is 5 greater than or equal to 5? Yes. Now, if this is yes, we're not going to increment the value or add 1 to the value of n. Since it says here that if this condition or let's say question is yes, we will end the flowchart. So that's how we ended this flowchart. And as you can see here, we have actually displayed numbers from 1 to 5. Okay? So that's it. So this is how you create a table. So make sure that you understand this. If you have any question, you could actually ask me through Messenger. Okay? So let's go back to our PowerPoint. Okay, so how about this? Create a flowchart to display 1 to n, where n is a user input. Okay, so a while ago, we created a flowchart that could only display from 1 to 5. But what if we want to create a flowchart that could display from 1 to n, where n is a user input? Let's say, for example, n is equals to 4, n is equals to 10. So it means that it is dynamic. Depends on the user if he wants to enter a number aside from 5. Okay? So we will use the previous answer, which is this. And then let's just try to improve it and make it dynamic. So this is the answer. So it says that we have to input a number n, set s is equals to 1, and then display s. So we will try to check, is n greater than or equal to n? So a while ago, we set this n as 5. So now we let the user to decide what would be the limit of that this flowchart. And then again, we just replace n here as s. Okay, and then going to display it. So we just added another instruction here, which is n, to decide which number will end this algorithm. So for example, 1, so we will display 1. Is 1 greater than or equal to 1? If yes, then it will end, it only displays 1. If the number n is 2, we set s is equals to 1, display s, which is 1. Is s greater than or equal to 2? No. So plus 1 to s, it will become 2. We will display 2. So we have 1, 2. And then we're going back again here in the decision table. So is 2 greater than or equal to n, which is 2, then it becomes yes. Okay? So if we try to create a table of this, so we're just gonna need another table for n. So input n, let's say maybe we could just move this to another cell. And then we have s, which is 1. Let's say n is equals to 3. And then display s instead of n. S is greater than or equal to n. And then s is equals to s plus 1. Okay? Now, for example, I imagine that n is 3 and then s is 1 initially via flowchart. Okay? Now, we will display s, so this is 1. Now, we will check in our decision shape if is n greater than or equal to n. Since 1 is less than 3, okay? So, if that's the case, we will just add 1 to n, or we will display, we will check if this is greater than or less than. So since 1 is less than 3, so s is less than 3, so we will add 1 to n. So we will put no here. So going to set s is equals to s plus 1. So s is currently 1 plus 1, so it would become 2. And then we will display s again. It would become 2. And then after that, we will go to our decision shape. Is n or is s greater than or equal to n? Our s is currently 2. Okay? 2. Is it greater than or equal to 3? So it's no. Since it's no, we will add 1 to n. And it will make s equal to 3. Okay? 2 plus 1 is 3. And then going back to our display, we will display 3 since s is equal to 3, currently 3. And then going to our decision shape, is s greater than or equal to n, which is 3. Actually, they are equal. That's why it would become yes. And if it's yes, it will go to the end, end of the flowchart. Okay? So that's how we trace this flowchart using a table. So make sure that you know how to create a table. It's really easy to create a table. So you just need to put all of this value as a column. Let's say, for example, n. So we input n here. S as 1. Display s. So what would be displayed? And then we have also the decision, which is this one. You just need to put the condition here. And then set s is equals to s plus 1. So you just need to include the operation to be used. And then refer to the value of s. Okay? So going back to our presentation, so we have another flowchart or example. So create a flowchart for checking or to check and display if a number entered by the user is greater than, less than, or equal to 5. Now, if we're going to make a flowchart, let's say kind of this one, we will need a multiple decision shape, multiple diamond. Now, we go to start, and then we will input a number n, since we want to identify if a number n is greater than, less than, or equal to 5. So we need a value to be determined, and that's n. The next one, we need to check if that is greater than. Now, if n is greater than 5, and it is yes, it will display n is greater than 5. Now for the case of no, we will check again. Is n less than 5? Now if yes, we will display n is less than 5. Now for the case of no, well, definitely if n is not greater than 5 and not less than 5, then definitely that's equal to 5. So we just need to display it without checking it. Okay? Do you get the logic? So this is actually if n is not greater than 5 and n is not less than 5, then definitely it's equal to 5. Okay? So it will not, our flowchart will not go here if one of these conditions is true. Okay? Now, after getting the, displaying this, the appropriate display for this flowchart, we just need to point it to the n. Okay? For example, n is equals to, I assign n to 8. Okay? So input n, number n. So I think of a number for n. So for example is 8. Now is 8 greater than 5? Yes. So they will display 8 is greater than 5, or display n is greater than 5, and then end. Okay? Now for example, I imagined n is equals to 4. So we will go here. I imagined n is equals to 4. Is 4 greater than 5, or is n greater than 5? It's not. If it's not, we will go here, the right side, the next decision shape. We will check if the number n is less than 5. So since our n is less than 5, it will go to yes, display n is less than 5, and then we end it again. Now if this is still no, let's say for example, we assign n is equals to 5. For example, in our head, you just need to imagine it, the value. So let's say for example, n is equals to 5. Now is n greater than 5? No. Is n less than 5? No. Then we just need to display n is equals to 5 and then end it again. Okay? So that's all for this flowchart. Now, we have this another one, pseudocode. So another way of representing a program or program flow in a much easier way than in an algorithm. So in a pseudocode, it's like a combination of English text or English words or sentences with some program syntax. Okay? But from other textbooks, we say that a pseudocode is a method for describing computer algorithms that combines natural language with programming. So when we say natural language, that's English language or Filipino language, but most of the time it's actually English. Okay? Now, here are the rules in constructing pseudocode. So the arithmetic operations are represented by the standard symbols plus, minus, asterisk for multiplication, and then slash for division. And then we also have here the double asterisk. It only means that we are going to raise a number to another number. So for example, 2 double asterisk 3. So we're trying to tell to the compiler or to the reader that it's 2 raised to 3. Okay, it's like 2 times 2 times 2. Okay, so that's 2 times 2 is 4, times 2 it's 8. Okay, so that's it. And then next, keywords like print, write, read, and others can be utilized. So as you can see here, these keywords are written in capital letters. So mostly those keywords are action words. Okay, and it holds a special meaning. Okay, it holds a special meaning. It has distinction to variables and other values that you can see in a pseudocode. So indentation should be used to indicate instruction loops and branches. Okay, so we use indentation class in order for us to group some block of codes that is dependent on the previous. Okay? So for example, it says here that in example 1, write a pseudocode for identifying if a number is even or odd. Okay? So we will try to create a pseudocode for this. Actually, we already have the answer. So as you can see here, we have begin and end still. And then we have here the read number. So meaning to say, if we are going to read a number, meaning to say this number here is a user input. So the user will decide what would be the number, what will be entered a number. Okay? So we will just think of a number. We're not going to put it here. Okay? We're not going to put it here. We're just going to think of a number. Okay? Now, after thinking of a number, let's say for example 8, okay? So if number modulo 2 is equals to 0, okay? So this is your variable. If number modulo 2 is equals to 0, then print the number is even. Else print the number is odd, and then end if. So if, else, and then end if. Now, as you can see here, class, uh, why do we need to indent this part? Okay, so why do we need to indent print in our if? Okay, we also indented print in our else, but why? Okay, so the reason is that, let's say for example we have a if here, we have an if, we also have a print, so it's not indented like in our example. Okay, print. So this is a keyword, like it's used to display a text or number. Okay, now the difference of this if and then indented print is that this instruction is dependent, and it will only be printed if number modulo 2 is equals to 0. So this instruction, print the number is even, is highly dependent on the previous line, which is this if part. This would only be printed if this is true. Okay? Unlike on this one, which is not indented, whatever the evaluation of this if could be either yes or no, it would still print. It doesn't depend on this if. Okay? If this is false or if this is true, this print here will still print whatever the evaluation of this if. While this one, this print on our example, is highly dependent on our if. If our evaluation here is false, this instruction here will not print. If this is true, that's the only time that this will be printed. Okay? So this print here is highly dependent on our if. If this is true, it will be printed. If not, it will not be printed. Okay? Unlike on this one, if we did not indented this print, so whatever the evaluation of the interpreter, or let's say compiler in our if, either true or false, it would still be printed. Okay? Same goes for else. So else is actually a like a catch-all. If this is false, it would print this one. Print the number is odd. Okay? And then end if. So we need to include end if so that the user knows that there is no more branch of this if. So we're trying to end this if here at this part. Okay? And then we could make another if here if we want. Okay? So begin, read, if, else, and then end if, and then end. Okay? Okay, so the next one, write a pseudocode for adding numbers from 1 to 5. So 1 plus 2 plus 3 plus 4 plus 5. Okay, so we set a value to sum. And then we also have set I to 1. So what is the difference between read and set? So read is for the user input. So we will just try to imagine a number for it. So we're trying to assign a value. This is a user input. Now, if we try to initialize a variable to a value, that's when we use set. So if you want to create a variable with an initial value, we use set. Now, if we want a variable to be uh, entered by the user, or let's say the value for the variable is entered by the user, we need to use read. If we want to set an initial value to a variable, we use set. Okay, so as you can see here, our variables already have their own value. So set sum to 0, set I to 1. Okay? So while, what is while? In Tagalog, while is habang. Okay? While I is less than or equal to 5, do set sum to sum plus I and set I to I plus 1. Okay? So let's try to create a table for this. We could actually also create a table for this. Okay? So set sum, set I less than or equal to 5, set sum to I plus sum plus I, sum plus I, and then we also have this one, I is equals to I plus 1. Okay? So currently our sum is equal to 0, I is equals to 1, and then is I less than or equal to 5? Actually it's yes, since I is equals to 1, and it's less than 5. Okay? Now what are we going to do? So we're going to reassign the value of sum. So sum is 0, okay, plus I, which is 1, so sum is 1. Okay, sum is currently 1. And then we add 1 to I. So I is currently 1, plus 1 is 2, so the new value of I is 2. Okay, we're going back to our while. Is 2 less than or equal to 5? Yes. So this is yes. Now we add 1 to I, or we add sum to I. So our sum is currently 1 based from our previous iteration, plus I, which is currently 2. So 1 plus 2 is 3. And then I is currently 2 plus 1, this is 3. Okay, so going back to our condition in while loop, so 3 less than or equal to 3, so this is yes. And then sum is actually 3, currently 3, plus I, which is also 3, so this is 6. And then currently I is 3 plus 1, this is 4. Now going back to our condition is I, or while I is less than or equal to 5, so I is 4, it is less than 5, that's why this is yes. Now we will add I to sum, so sum is 6 plus I, which is 4, so this is 10. And then we will add 1 to I, which is 5. So 4 plus 1 is 5. Now we will go back again. We will check if I is less than or equal to 5. So 5 is less than or equal to 5. So this is still yes. And then here, we will just add I to sum. Sum is currently 10. And then I is currently 5. So 10 plus 5 is 15. So that's the new value of sum, and then we will add 1 to I. So 5 plus 1 is 6. Okay? So we will go again to our while loop. So is I, which is 6, less than or equal to 5? No. So that's the time that we ended this while loop. Okay? So that's why we end this while loop. So after that, we print the sum is plus sum. Okay? So the current value of sum is 15. So 15 will be displayed on this pseudocode. So what is plus sign here? So this plus sign here is trying to tell us that we're just going to connect the variable sum, which is 15, to this text. The sum is. So the sum is, and then whatever the value of sum, the ending value of sum, will be connected to this. So the sum is 15. Okay? So this one is a string or just a text, and then this one is a number. So the sum is and the number, so we'll just combine them using the plus symbol. Okay? So we have another one, write a pseudocode for displaying hello n times. So when we say n times, we will determine if how many times the pseudocode will display hello, and it depends on the user input. Okay? Now we will try to create a table for this. So read n, so whatever the n is. So I is initially 1, and then the condition is I less than or equal to n. And then we have set I to I plus 1. So I is equals to I plus 1. And then end while. Okay, so for example, n is equal to 3. Okay, in my it's just a I just assume a number for n. Okay, just to try this pseudocode, I will think of a number, or I would think of a number. Let's say n is equals to 3. Okay, and then we will check, or after setting a value for n, so this is 3 for example. Now we will set I to 1, so this is 1. Now we will check while I, as long as this is true, it will print hello and then set I to I plus 1. So is I less than or equal to n? So our I is 1, and it is less than or equal to 3. So this is yes. And since it is yes, it would print hello. Okay, so we will print hello. Print, and then hello. And then set I is equals to I plus 1. So I is 1 plus 1, so this would become 2. Going back to our condition, is 2 less than or equal to n? Yes, because 2 is less than or equal to 3. It would print hello. Yes, hello. And then plus 1 to I. So this would become 3. Is 3 less than or equal to n? It's still yes. And then hello. And then I plus 1. So I is 3 plus 1. So this is 4. Now going back to our condition, is 4 less than or equal to n? No, it's greater than. So that's why we're not going to print hello. And that's when we end the while loop. Okay? And then end. So this is how you create a table for this. You just need to put all of this instruction as a column and then trace the value going down to until it ends. Okay? Okay, so try this. Write a pseudocode that adds two numbers entered by the user.